In this lesson, for Chapter 2, we're beginning to talk about functions and what a function is in mathematics. So for this first part, we're going to talk about how do you tell if something is a function? What do we mean by it? And in order to talk about functions, we have to talk about relations. So a relation is a set of input and output values, or a set of ordered pairs. Remember, normally we think of ordered pairs as being x's and y's, and that's exactly what a relation is. It's some x and some y together. So the input values here, those are the same as the x values, and we call those the domain, whereas the output values, or the y values, those are what we call the range. So those two words come into play when we talk about a relation. And so here's an example of some ordered pairs on a coordinate plane. We're going to list the ordered pairs so that we can see what the relation is. Remember, that's the collection of the ordered pairs. And then we're going to state the domain, or the x values, and the range, or the y values. So, ordered pairs for this one here. Ordered pairs will be -4, 4 for this guy. -2, 4. We have 3, 2. We have -3, -2, and we have 2, -4. So these here, these are the ordered pairs. Okay. When we talk about the domain, we're going to use this color for domain. We're listing only the x values, right, for domain, only the x values. So -4 and -2, typically though we go in numerical order, so -2 is one of them, but I'm going to leave a space because we also have a -3. Then we have a +2 and a +3. Those are all the domain, or all the x values of this relationship. All the range values, or the y values of this relationship. Let's see, what's the smallest one we have here? We have -4, and we have -2, +2, and +4. Now notice we had the +4 twice. I'm only going to write it once right here. So you don't have to repeat when you have more than one. So you don't always have a matchup for all of these numbers. So this one is the relationship, okay, or the relation. These are your ordered pairs. The domain are the x values, the range are the y values. And again, we're got to see this numerically, and right here you saw it graphically. Another way we can organize our domain and range values is with a mapping diagram. A mapping diagram shows the relationship between inputs and outputs, or it shows the relationship between domain and range. A numerical representation. So here are some more ordered pairs, and a mapping diagram looks like this. We make a section for all the domains, we make a section for all the ranges, and we're going to list all the x's. So -1 here, 1, 1, I already have it, and -1, I already have it. Then we have 7, and 3, 7, and 3. And again, I already have those. Now, to make the mapping diagram complete, we have to show how you get from one to the other. So -1 is connected to 7. So we're going to draw a line like this. 1 is connected to 3, so we draw a line here. 1 is also connected to 7, so this one gets a second line going up. And -1 is also connected to 3, so this one comes down. That's a mapping diagram. It shows the numbers, and it shows who's connected to who. Now, a function is a special kind of relation where every input has exactly, this is important, has exactly one unique special output, where every input has exactly one unique special output, or another way to say it is that every x value has exactly one unique special y value. Okay. So a function, that would be our, our verbal right here, would be what we just said. That's our verbal definition. Not a function is where an x value has two or more y values attached to it. Numerically, so for example, thinking about our mapping diagrams that we just saw here, if you have your domain and you have your range, okay, and let's say you have 1 and you have 2 and you have 3, and then over here we have 10, 20, and 30. 1, 2, 3, 10, 20, and 30. A function would be where the 1 is connected with a 10. Let's say the 3 got connected to the 20, and the 2 got connected to the 30, but each one of them has a unique y value coming out. What's not a function is when 1 goes to 10, 2 went to 10, that's still okay because this 2 has a unique 10, that's fine. What's not okay is when 2 has a second line coming out from it going to 2. And let's say then the 3 went to the 3 over here. Let's put another numerical representation just so you can see what's okay over here for a function. Okay, domain and range. So let's say you have 1 and 2, and we have 5 and 6 over here. It's okay for 1 to go to 5. It's okay for 2 to go to 5. And then just if you didn't use the 6 or something, that's okay. What's not okay is when this guy has 2 lines heading out from it. That's what's wrong, okay? It's okay if 2 x's go to the same y value. It's not okay when 1 x splits like that. So graphically, we talk about something called the vertical line test, which we'll see in just a second. But basically, any of these functions here, these are all okay for functions because every x value you can think of will have a unique y value, just 1 point apiece. So -5, and let's say that's a 3. Okay. What's not a function is when you have something like this, and you have an x value here, say -5, and look at that. There's a y value up here at +6, and a y value down here at -4. There's 2 points for just that one little -5. He gets 2 different places. That's not a function. Algebraically, something is a function if it has y equals, and you can have any sort of x's over here. Y equals x squared, y equals x cubed. Let's say you add a +6. Y equals -2x plus 7. Those are all fine. What's not okay for a function is to have something like a y squared equals x. That is not a function when the y has the squared, okay? Or when the y has the fourth or something like that. Those are not functions, because you have 2 different y's for the same x, or 4 different y's for this same x. Let's go ahead, we'll take a look at some examples. When we talk about domain and range for your mapping functions here, we want to determine whether each relationship is a function. Remember what we said about things splitting. We said every x has a unique y value. So look at your x values over here. We have -3. So looking at this x value here, think about the -3. He's going to a 4, but wait a second, then he splits and he goes to a 5. So he's not having two unique, he doesn't have a unique y value. He's splitting. So this one, not a function. We don't even keep checking. As long as that point fails, we know the whole thing is not a function. This one here, 2 just goes to -2, so we're good. He has a unique value. But then 4, look at this, 4 splits. And so because 4 splits, this one is also not a function. Here's a fun way that you can remember too if something's a function or not a function. Think about this column being the people column and this column being the birthdays column. So -3 can't have 2 birthdays, right? -3 cannot have a birthday on the 4th of September and the 5th of September. It has to have only one birthday. 2 can have a birthday on -2, but 4 cannot have a birthday on both -2 and 5. So that's a quick and fun way to check if something's not a function. Every person or every x must have one unique birthday or one unique y. So that's numerically. Then there's the vertical line test. This works for graphs. If a vertical line passes through 2 or more points on a line or on a graph, remember when we say line in math, it could mean a straight line or it could mean a curved line. What we mean by this is a graph. So if a vertical line passes through 2 or more points on a graph, then it is not a function. So for example, here's a graph. Use a vertical line test to determine. So if we have, if I take this line here and we think about moving it, see how this line only ever hits one point on that red graph at a time? Okay, it never hits more than once. So we're okay. This one we'd say, yes, it's a function. Now, let's try a different graph here. Let's say I have a squiggle line going this way, and this one is my graph. Now when I take my vertical line and I test it, wait, look, stop here. See how I have it's hitting here, it's hitting here, and it's hitting here? It hit 2 or more points. So this one is not a function. So when we're talking about a function, remember it's some connection between x values, input values, domain values. All those words mean the same thing. And some connection between y values, output values, and range values. All those mean the same thing. The main idea is that one x goes to a unique y. You cannot have a split. When you have x going to 2 different things, that's not a function. Okay? But as long as it has only one unique y value, then we go ahead and we call this one a function. And we looked at what does that look like graphically. We used the vertical line test. We looked at numerically when you put them in these mapping diagrams, thinking about peoples and birthdays. And we'll talk a little bit more about algebraically later in this chapter. You'll get to see what that looks like. But basically, as long as you have one y, you're good. If you ever have y squareds, that's a problem. Okay? So that is our functions.